Assalamu alaikum. Hello, hi. Today we study chapter number 3, topics in differentiation, exercise 3.6. In exercise 3.6, we study a Lepter rule. And what is a Lepter rule? That's a Lepter rule has two cases. Case one is that if we put limit in a function, we have the form of 0 by 0 or infinity by infinity. Let's suppose we have a function limit x approaches to 0 sine 2x divided by x. If we put limit in this function, we have the form of 0 by 0. So what can we do? This is case 1 of a Lepter rule. So what can do in that type of function? We simply take separate derivative of numerator and separate derivative of denominator. Take derivative. If we take derivative, we have 2 cos 2x and divided by derivative of x is 1. Now if we put limit, so we have 2 cos 2 0 cos 0 is 1, so we have 2 1 equal to 2. And case 2, for case 2 we have the form of 0 by power 0, 3t power 0 and 1 power infinity. Let's suppose we take a function limit x approaches to 0 1 plus sin x divided by 1 by x. If we put limit to that function, we have the form of 1 by infinity. So there are 3 to 4 steps to solve this type of question. Step 1 is that let function is equal to y. 1 plus sin x 1 by x. This is our step 1. Step 2 is that take ln on both sides. Take ln on both sides, so we have ln y is equal to ln 1 plus sin x 1 by x. Use property of log, so we have 1 by x in start, ln 1 plus sin x. Now after this step, step 3 is take limit that you have given. Limit x approaches to 0, ln y is equal to limit x approaches to 0, 1 by x, ln 1 plus sin x. Now ln y is constant, so limit can't apply with this function, so we have ln y as it is. For this function, multiply and divided by x. Don't For this function we take this function as it ln 1 plus sin x divided by x. Now if we put limit in that function, so we have 0 by 0 form of 0 by 0. So now we take separate derivative of numerator and separate derivative of denominator. So we have limit x approaches to 0. Derivative of ln 1 plus sin x is 1 by 1 plus sin x, and derivative of dot cos x, and derivative of denominator is 1. If we put direct limit in that function, we have ln y cos when we put x is equal to 0, cos 0 is 1, sin 0 is 0, so we have ln y is equal to 1. Step 4 is that take exponent on both sides. Take exponent on both sides, so we have y is equal to e. Y is our function, we know y let is equal to 1 plus sin x, so our answer is limit x approaches to 0, 1 plus sin x 1 by x is equal to e. So that is our answer. There are two steps to solve by L'Hopital rule method. Now we are going to exercise starting from question number 7. Question number 7, we have limit x approaches to 0, ex minus 1 divided by sin x. If we put limit, so we have the form of 0 by 0. So now take derivative, separate derivative of numerator and denominator. So we have derivative of ex is ex, and derivative of 1 is 0, and derivative of sin x is cos x. Now if we put limit, so we have e naught divided by cos 0, 1 divided by 1 equal to 1. The other question is question number 8. Limit, this is our answer of question number 7. Limit x approaches to 0, sin 2x divided by sin 5x. If we put limit, so we have the form of 0 by 0. We apply case 1, take separate derivative of numerator and denominator. Derivative of sin 2x is 2 cos 2x, and derivative of sin 5x is 5 cos 5x. Now if we put limit that function, we have 2 cos 0 divided by 5 cos 0. We have 2 by 5 our answer. Question number 9. Question number 9 is that limit theta approaches to 0, tan theta divided by theta. Take derivative of separate derivative of numerator and denominator. Theta approaches to 0. Derivative of tan theta is secant square theta, and derivative of theta is 1. Now put limit secant theta square, limit theta approaches to 0. Put limit, so we have secant 0 square. Secant 0 is 1, 1 square equal to 1. So 1 is our answer. Question number 10. Limit t approaches to 0, t at divided by 1 minus at. If we put limit, we have the form of 0 by 0. Now take derivative. Limit t approaches to 0. Derivative of t at, we apply product rule on this function. So we have t dot at plus at and divided by minus at. Now take at common from numerator. So we have at t plus 1 divided by minus at. T approaches to 0, t plus 1. Now we put limit, so we have 0 plus 1 equal to 1 is our answer. Question number 11. Limit x approaches to pi, right hand side. This sign is for right hand limit. Sin x divided by x minus pi. If we put limit that function, we have the form of 0 by 0. Now take derivative, separate derivative of numerator and denominator. Derivative of sin x is cos x. Derivative of x is 1. pi is constant and constant derivative of constant function is 0. So cos x divided by 1, we put limit in that function, cos pi. So cos pi is equal to minus 1. So minus 1 is our answer. Now go for question number 12. Limit x approaches to 0, sin x divided by x square. If we put limit, we have the form of 0 by 0. Now take derivative, separate derivative. Derivative of sin x is cos x, and derivative of 2x square, x square is 2x. If we put limit, we have cos 0 divided by 2 0. Cos 0 is 1. 1 divided by 0. 1 divided by 0 is equal to infinity. So infinity is our answer. Question number 13. Limit x approaches to plus infinity ln x divided by x. If we put limit, we have the form of 0, infinity by infinity. Now take the separate derivative. Limit x approaches to plus infinity. Derivative of ln x is 1 by x, and derivative of x is 1. So we have limit x approaches to plus infinity 1 by x. If we put limit to that function, we have 1 by infinity, and 1 by infinity is equal to 0. So that is our answer. Question number 14. Limit x approaches to plus infinity e exponent 3x divided by x square. If we put limit to that function, we have the form of 0 by 0. Now take separate derivative. Limit x approaches to plus infinity. Derivative of e 3x is 3x, and derivative of x square is 2x. Now again, if we put limit in that function, we have the form of 0 by 0. So we take again derivative of this function. Limit, if we put limit, so we have the form of infinity by infinity. Limit x approaches to plus infinity. If we take again derivative, we have 9 a 3x divided by 2. Now if we put limit, we have 9 e 3 infinity divided by 2. 9 by infinity divided by 2 is equal to 9 by 2. Infinity is equal to infinity is our answer of question number 14. Now question number 15. Limit x approaches to 0 plus, this sign is for right hand limit, what x divided by ln x. If we put limit to that function, we have the form of 0 by 0. Now take derivative. Derivative of cot x is minus cosecant square x divided by derivative of ln x is 1 by x. Now if we put limit, so we have the form of x. Cosecant 0 is 0, and 1 by 0 is infinity. Now if we take again derivative, we also put direct limit to that function because we don't have the form of infinity by infinity or 0 by 0. If we put limit, we have minus cosecant 0 square divided by 1 by 0. 1 by 0 is equal to infinity, and cosecant 0 is 0. So this is 0 by infinity, we also say infinity. So next question is question number 90. Limit x approaches to 0, sin inverse 2x divided by x. Now if we put limit, we have the form of 0 by 0. We take derivative, separate derivative. Derivative of sin inverse 2x is 1 divided by under root 1 minus 2x square, and derivative of denominator x is 1. Now we have function limit x approaches to 0, 1 divided by under root 1 minus 4x square. Put limit, we have so 1 is our answer. Next question is question number 20. Limit x approaches to 0, x minus tan inverse x divided by x. If we put limit, we have the form of 0 by 0. Now take derivative. Limit x approaches to 0. Derivative of x is 1, and derivative of tan inverse x is 1 by 1 plus x square, and derivative of x cube is 3x square. Solve this function. Limit x approaches to 0, 1 plus x square divided by 3x square. We have 1 plus x square minus 1. We have limit x approaches to 0, x square. We also said 3x square dot 1 plus x square. This x square is cancelled from this x square. Now if we put limit, we have 1 by 3, 1 plus 0 square. So 1 by 3 is our answer. Next question is question number 24. Limit x approaches to 0, tan x dot ln x. Now for this constant, we change tan x into sin x divided by cos x. So we have that. If we put limit in that function, we have the form of 0 by 0. Now take derivative. X approaches to 0. Derivative of sin x ln x is sin x dot 1 by x plus ln x. Derivative of sin x is cos x, and derivative of cos x is minus sin x. Now we have limit. If we take LCM of this point, we have minus x sin x, x sin x plus x ln x cos x. Now if we put limit in that function, we again have the form of 0 by 0. Now we take again derivative of this function. If we take again derivative of this function, so we have the answer of this point. Now we'll go to the next question. Question number 27. Limit x approaches to infinity, 1 minus 3x divided by 3 divided by x power x. This type of question solved by case 2. For this, let y is equal to 1 minus 3x divided by x. If we put direct limit in that function, we have the form of 1 by infinity. So we apply case to step 1 is that let y is equal to the function. Step 2 is take ln on both sides and use property of ln v. So we have x ln 1 minus 3 divided by x. Step 3 is that take limit on both sides. The limit we have given in the function limit x plus infinity ln y is equal to limit x plus infinity x ln 1 minus 3 x ln y is constant, so we have ln y as it is. For this step, multiply and divided by 1 by x, so we have multiply and divided by 1 by x, so we have limit x plus infinity ln 1 minus 3 by x divided by 1 by x. Now take derivative of this point, because if we put limit into that function we have the form of infinity by infinity. If we take derivative of this point we have ln y is equal to limit x approaches to negative derivative of ln 1 minus 3x is 1 divided by 1 minus 3x dot derivative of 1 is 0 and derivative of 3 minus 3 divided by x is 3 by x square and divided by derivative of 1 by x is minus 1 by x square. This x 1 by x square cut from this, so we have ln y is equal to limit x plus infinity and 1 3 divided by 1 minus 3 by x divided by minus 1 ln y is equal to limit x plus infinity, so we have minus 3 divided by x minus 3 x this one goes to the numerator, so we have minus 3x divided by x minus 3. If we put limit in that function we again have the form of infinity by infinity, so again derivative of this point, so we have ln y limit x approaches to plus infinity minus 3 derivative of minus 3x is minus 3 and derivative of x is 1, so we have ln y minus 3 is constant, so comes as it is. Now step 4 is take exponent on both sides, so we have e is equal to y is equal to e minus 3. Now so e minus 3 is our answer. We can say that limit x approaches to plus infinity 1 minus 3 by x equal to e minus 3 is our answer. Next question is question number 28. Limit x approaches to 0 1 plus 2x minus 3 by x. If we put limit at that function we have the form of 1 by infinity. So now solve by case 2. Step 1, let y is equal to the function 1 plus 2x minus 3 divided by x. Step 2 is take ln on both sides, use property of ln, so we have minus 3 divided by x ln 1 plus 2x. Step 4 is that take limit on both sides. Limit x approaches to 0. Ln y equal to limit x approaches to 0 minus 3 ln 1 plus 2x divided by x. If we put limit at that function, we have the form of 0 by 0, and ln y comes as it is. Now take derivative, separate derivative of numerator and denominator. So we have minus 3 dot 1 by 1 plus 2x dot 2 divided by 1 ln y is equal to we put limits in that point, so we have ln y is equal to minus 6. Take exponent on both sides, so y is equal to e minus 6. So e minus 6 is our answer. So next question is question number 29. Limit x approaches to 0. Ex plus x 1 by x. If we put drag limit in that function, we have the form of 1 by infinity. So solve by case 2. Step 2, take ln on both sides and use property of ln. We have x 1 by x ln ex plus x. Take limit on both sides. Limit x approaches to 0. Ln y. Limit x approaches to 0. Ln ex plus x divided by x. Ln y comes as it is. For this point, take separate derivative of numerator and denominator. Limit x approaches to 0. Derivative of ln ex plus x is 1 divided by ex plus x, and ex plus 1 divided by 1. So we have ln y equal to limit x approaches to 0 ex plus 1 divided by ex plus x. If we put limit at that function, we have a naught plus 1, a naught plus 0, a naught is equal to 1, 1 plus 1, 1. So we have ln y equal to 2. Take exponent on both sides, so we have y is equal to a2. So e square is our answer. Next question is question number 34. Limit x approaches to 0. 1 by x square minus cos 3x divided by x square. First step is that take LCM. So we have x square 1 minus cos 3x. If we put limit in that function, we have the form of 0 by 0. So solve by case 1. Take derivative, we have 3 sine 3x divided by 2x. If we put limit, we again have the form of 0 by 0. Now again take derivative. We have limit x approaches to 0 minus 9 cos 3x divided by 2. Now if we put limit to that function, we have minus 9 cos 0 divided by 2. So minus 9 by 2 is our answer.